Sir, good afternoon, all. Am I audible?
Yes, sir.
Okay, okay. Okay, sorry for late due to some emergency work. I think I'm 10 to 15 minutes late. Okay, I will start now. Okay, in last lecture, we have finished our heat treatment processes. Means in that we have completed our four heat treatment processes which are in our syllabus related to the heat treatment of the steels. In that we have discussed annealing, normalizing, hardening, and tempering, along with their types. You can say that I will tell you point wise all these processes, in that we have studied their purpose, then the procedure to conduct that heat treatment process, then their different types and their applications. And we have also learned about the concept of retained austenite, then what is the effect of the retained austenite, and how the elimination of the retained austenite is done. Uh, then after this, we will move towards the next point, that is the surface hardening. Uh, this is this you can say that in general, that is this is the surface treatment process. It is also known as surface hardening or case hardening. Okay. Now there are several types of this surface hardening processes or surface heat treatment processes that we will discuss in the later half of this lecture. Before that, we will first I will introduce related to this surface hardening process. Why conduction of this surface hardening process, or simply you can say that surface heat treatment process, why it is necessary. So first of all, in many applications, like I have mentioned here, that is, suppose some components are there, like crankshaft, camshaft, gears are there, flywheels are there, then different buckets which are we are using for the tractors and other equipments. In that, different teeth buckets are there. For that, whichever component we are using, for that, that component should have whichever surface is present, that surface should be hard and wear resistance. And along with that, whichever core is present, core means center of that component, it should have sufficient toughness so that it should withstand the impact load. Okay, all these components like crankshaft, camshaft, gears are there. What are the required properties, basic properties? Its surface should be hard and wear resistance, and its center part or core part, it should be tough so that it can able to withstand the impact loads, whichever loads are acting on that component in the actual practical use. At that time, it should sustain. For that, it should be tough at center, and on the surface it should be hard and wear resistance. So these properties are needed in the different components. Now, to achieve these properties, if you can go for low carbon steel. Suppose uh, if you used the low carbon steel, then low carbon steels will provide you the toughness. It will provide you the required toughness, but it is almost impossible to get the required hardness with help of that low carbon steel, and it is a non hardenable steel. Then you have another choice, that is, you can go for the high carbon steel. High carbon steel will provide you the required hardness and wear resistance, but that high carbon steel, that material, it will not be able to provide you the required toughness, that toughness required to withstand the impact loads during the practical use. So that, in this way, you cannot go for the low carbon steels, as well as you cannot go for the high carbon steels. The remaining choice will be medium carbon steel, but due to that medium carbon steel, you are not you will be not able to get the required hardness. Means hardness will be not up to that maximum level, and toughness will be at the medium level, so that you cannot get the optimum level, so that you can use that steel material to manufacture the required component. So the option, the choice remained will be, you have to do the surface treatment. Okay, you can do the surface treatment. You will select the low carbon steel which is having the toughness, and you will change the composition. Either you will do the surface hardening in the two ways. I will explain it. That surface hardening can be done in two ways. The first way will be by changing the composition of that steel. Okay, you can change the composition of that material. Or second option will be without changing the composition. In the first option, with changing the composition, you are having three choices. Your first choice will be by increasing the amount of carbon. Your second choice will be by increasing the amount of nitrogen on the surface. And your third choice will be by increasing the amount of carbon and nitrogen both. And all these changes in the composition we are doing on the surface only. So these are the three types, you can say that in simple ways. You can do the surface treatment process in two ways: by changing the composition and without changing the composition. In by changing the composition, there will be three subtypes. In the first types, you can increase the amount of carbon on the surface, and that steel material will be followed by one more heat treatment process, or subsequent heat treatment processes will be there, that we will discuss in brief in the different types of the surface hardening processes. And second type will be, you can introduce the nitrogen on the surface. Nitrogen on the surface, due to introduction of nitrogen, that surface will become hard and wear resistance. And whenever you are introducing only nitrogen, no further heat treatment is required here. And the third type will be introduction of carbon and nitrogen. Whenever you are introducing carbon, it will require further heat treatment process. And here, in the third type, we are using carbon and nitrogen both. Then you will get the hard and wear resistant surface, but after performing the heat treatment process. Okay, first you will introduce the carbon, followed by heat treatment process. Then second choice will be introduction of nitrogen without any heat treatment process. And third will be introducing carbon and nitrogen both, followed by a heat treatment process. These three types will be there, and these three surface treatment will involve the change in the composition of that steel. Then the main second type of the surface heat treatment process will be without changing the composition. And in this without changing the composition of the surface, two types of the heat treatment processes are there: induction hardening and flame hardening. And how these different processes are conducted, and that we are going to discuss one by one. Now before that, I will just tell you the name. The first type, increasing the carbon on the surface. Increasing the carbon on the surface, this heat treatment process will be termed as carburizing. Increasing the carbon on the surface, it will be termed as carburizing. Then introducing the nitrogen on the surface, this heat treatment process will be termed as nitriding. Okay, whenever you are introducing the carbon, it will be carburizing. Whenever you are introducing the nitrogen, it will be termed as nitriding. And whenever you are introducing carbon and nitrogen both, that heat treatment process will be termed as carbonitriding. Okay, when for only carbon, it will be carburizing. Then for introduction of nitrogen, it will be nitriding. And if you are adding both carbon and nitrogen, then that process, heat treatment process, will be termed as carbonitriding. Okay, now we will start with the first type, that is the carburizing. Okay, this is the first heat treatment process, carburizing heat treatment process. Before starting this, just you can add just write down that 4 points to satisfy the requirement of optimum level. Following methods are used. Please note down these 4 points in short. Just in short, you can note down: increasing carbon, increasing carbon followed by heat treatment, introduction of nitrogen without heat treatment, then introducing carbon nitrogen both followed by heat treatment, and hardening of the surface without changing the composition. Please write down this. I will wait for 2 minutes, and after that we'll start the carburizing heat treatment process. Complete it and put that in the chat box that you have finished it. If you have finished, can I start that actual heat treatment, surface heat treatment processes? And it is first will be carburizing. Please mention that in the chat box, or you can directly reply me. Okay, now we will move towards the first surface heat treatment process. It is termed as the carburizing. It is also known as case carburizing. Case is nothing but the surface of that component. Okay, carburizing means we are increasing or introducing the carbon on the surface. In short, carburizing, in short, meaning of the carburizing process is a method of increasing or introducing the carbon on the surface. That process will be termed as the carburizing. And the surface is nothing. Surface is nothing. It is also known as the case. That's why it is also known as the case carburizing. And here, as we are introducing the carbon from another medium into that steel, this process is also known as the cementation process. Okay, now how this carburizing heat treatment process is conducted? It is also a heat surface. This is surface heat treatment process, and this is also a heat treatment process. And as we have earlier discussed, that any heat treatment process will consist of heating cycle, holding time, and cooling cycles. There may be one or more heating cycles or one or more cooling cycles may be there. Now here in this carburizing process, it will consist of, first you have to heat the steel component in the austenitic region. Okay, in the austenitic region you have to heat that steel component. Then while performing the heating process, now here you have to take care that whichever component is there, while you are providing doing the heating operation, this heating process will be done in the one medium is used here, carburizing medium or carbonaceous medium. Carburizing medium or carbonaceous medium, first component is placed in that carburizing medium or carbonaceous medium, and after that we are heating that component in the austenitic region. Then we are holding at this particular temperature for sufficient time, and after that we are cooling to the room temperature. Okay, this is the process how the carburizing is conducted. First, I will repeat it, steel component is taken, and that steel component is placed in the carburizing medium or carbonaceous medium, and togetherly these are heated in the austenitic region. Okay, in the austenitic region, and at that temperature we are holding that component for sufficient period of time. This will be holding time or soaking time to get the homogeneous austenite and equalization of temperature, and after this we are cooling that component to the room temperature. So this is the carburizing heat treatment process. Just it is very similar to the other heat treatment processes. Only while doing the heating, first that component we are placing it in the carburizing medium or carbonaceous medium. Here carburizing medium is nothing but the source, carbon source. You can say that from that medium only we are getting the carbon, and that is added in our steel component. Now, what exactly happens during this process? Carbon from the medium at the higher temperatures, it will means from that medium it will get separated due to the higher temperature range, and that separated carbon will get added into the steel, or you can say that at higher temperature austenite phase will be there. In that austenite it will get added. Okay, it will get added into that austenite, and after cooling, after cooling process that carbon will get transformed the martensite. Okay, that carbon should present in the form of martensite, then and then only it will improve the hardness of the surface. If carbon remains at as it is, it does not result in the increased hardness. Okay, that carbon should present in the form of martensite only. Okay, so that from austenite, when we do the cooling operation, that austenite will get transformed to the martensite. This process will occur. Okay, I will repeat it again what exactly happens in this process. From first we are taking the component, then that component is placed in the carbonaceous medium or carburizing medium, and it is heated at the higher temperature ranges in the austenitic region, means above 900 degrees Celsius. We are holding at that temperature for some you can say that sometimes it may be 30 minutes, or sometimes you have to wait for 10 hours, 15 hours, like that, depending on the medium used and type of the steel component. And during this heating process, what will happen? Carbon from that medium will get diffused into the austenite phase, and after doing the cooling, the hardening will occur in such a way that the austenite will get transformed to the martensite, and it will result in the improved hardness of the surface. In this way, this carburizing process or case carburizing or cementation process will occur. Now, depending on the carburizing medium used, if you have used the solid carburizing medium, then that carburizing will be termed as solid carburizing. If we have used gaseous medium, then it will be termed as gas carburizing. If liquid carburizing medium or carbonaceous medium is used, then it will be termed as liquid carburizing. In this way, depending on the medium used for carburizing is classified into three basic types: solid carburizing, gas carburizing, and liquid carburizing. Now, each type we will discuss one by one. Okay. If you are having any difficulty and in this process carburizing, how the general process is conducted, you can ask me. This is the basic part. And for this classification or these three types, only medium will be different, remaining procedure will be same. Procedure will remain same, only medium we are going to change. Okay. If you are having any query, put that in the chat box, and if you are not having any query, also mention that in the chat box so that I can proceed. Please put that in the chat box, or you can directly give me a reply. If you are having any query, you can ask me. Kindly provide me reply. Roll number 25. Okay. Yash Gadikar, are you there?
Yes, sir.
Okay. Can I proceed?
Yes, sir. You can proceed.
Okay, okay. We will move towards next type. Okay. Okay. Now, carburizing process has three types. First is solid carburizing, depending on the medium used. Now, uh, in books you can find that description, more and more description is given. I have sorted important points. This much description in your examination is sufficient. Okay, for as far as your final examination is, this much description and this reaction, this part is sufficient. Okay, you get the 4 marks for that. Don't go in brief description, just have to mention the important points. What are the important points here? Which medium you have used, then medium, that will be termed as carbonaceous medium or carburizing medium, then carburizing temperature, then time required for carburizing, and case depth achieved. Okay, depth achieved with the hardness, and if any advantages is there for that specific method, that you have to mention, and if any reaction is occurring, that reaction you have to write. This much description is sufficient. Okay, don't go for writing in very brief. Okay, now I will explain this solid. First type is the solid carburizing. Now the procedure will be same. First will be heating cycle. Steel component is here. I will explain directly instead of repeating it for carburizing only. In the solid carburizing, this center part, this is your component to be carburized. Okay, part to be carburized or component to be carburized. Component is taken and that component is placed or packed with carbonaceous medium. You can see surrounding, it is covered with the carbonaceous medium. And here in the solid carburizing, carbonaceous medium or carburizing medium will be solid in nature, and generally we are using the mixture of hardwood charcoal 53 to 55%, then coke 30 to 32%, and remaining amount of sodium carbonate or calcium carbonate and barium carbonate is used. Now here, these hardwood charcoal and coke, they will provide you the required carbon, or this is the actual source of the carbon. And this is sodium carbonate, or you can say that calcium carbonate or barium carbonate. These are added as the they will accelerate the process. They will just accelerate the process. For that purpose we have added these elements. Okay, now first we will take the component, then it is placed in the carbonaceous medium, and togetherly along with the carbonaceous medium and the component, these are placed or packed in the container made up of steel. This is the outer container. It is made up of steel or cast iron. Now this container is placed in the furnace and it is heated. Okay, this furnace we are this container or that box is taken. That box is placed in the furnace and it is heated in the austenitic region. And here the austenitizing temperature or carburizing temperature is 925 degrees Celsius to 950 degrees Celsius. Okay, in this temperature range that component is held for approximately 6 to 15 hours. 6 to 15 hours. And during this 6 to 15 hours, what exactly happens there? Now whichever medium we have used, okay, whichever medium we have used, from that carbon will react with, initially it will react with the oxygen element present in the box, and it will form the carbon dioxide gas. Again, suppose you have added the energizer or accelerator. Here barium carbonate reaction I have taken. Barium carbonate is added. It will get braked at the higher temperature range. It will get braked and it will form barium oxide and carbon dioxide. Then again, this whichever carbon dioxide gas is formed here, it will react with the carbon from that medium, and it will form carbon monoxide. And this carbon monoxide, it will get braked or it will get decomposed to form carbon element, and this carbon will get dissolved in the austenite. And whichever CO2 is released, again it will combine with the carbon from medium, it will form carbon monoxide gas, and this cycle is repeated here. Okay, this cycle is repeated again and again, and whichever carbon is forming here, it will get dissolved in the austenite. Okay, it will get dissolved in the austenite. And after sufficient amount of heating, that component is taken out from that furnace and it is cooled or quenched in the water or oil. And this carbon in the form of austenite, it will get transformed to the martensite, and we will end up with the desired hardness at the surface. Okay, so this reaction will occur, and in this way that carbon will get diffused and the solid carburizing process will occur. And whichever depth of hardening is achieved on the means surface depth, or you can say that case depth is achieved in this solid solid carburizing process, we can achieve 1 mm to 2.5 mm case depth. Okay, this can be achieved. And out in these three types, solid, liquid, and gas carburizing. Solid carburizing takes more time. It will take more time, as it is a very slow process. You can see here it requires more time for the carburizing. It takes more time. And whichever depth is obtained, case hardened depth, means hardness achieved is non-uniform. Because of the distribution of the carbon will be non-uniform, and it will end up with the non-uniform layer or non-uniform hardness on the surface. This is very slow process. And whichever case depth or case is obtained or surface is obtained, it will have non-uniform hardness. Okay, these are the disadvantages of this process. Takes more time, and it will give you a non-uniform case or non-uniform surface will be obtained in this case. Then the second type, this will be the reaction. And now one more thing, the solid carburizing process is also known as pack carburizing, or it is also known as box carburizing. Why name is given as pack or box? Because we are packing that steel component on which we are going to perform the carburizing process in a steel or cast iron container. Along with the carbonaceous medium, we are packing that. That's why it is termed as pack carburizing. And this is packed in a box or container of steel or cast iron. Hence, it is also known as box carburizing also. Okay. So this is the solid carburizing. Then after this solid carburizing, you have to write these points. You have to draw the diagram and draw the reactions. And after this, and the second type is the gas carburizing. Okay, procedure will be same, just we are going to change the medium, temperature, and time. Okay, here in the gas carburizing, as the name itself will indicate, that the medium used for carburizing is the gaseous medium. Here we are going to use. Now the components are heated in the austenitic region in the presence of carbonaceous gas. For example, you can use methane, ethane, and propane, butane, along with the inert gases. To control its flow, we are using all the gases in the inert gases. Inert gases means they does not take the part in the reaction. Just they will provide you that required flow. It will just provide you the required control. And here we are going to use the inert gases like helium, argon, nitrogen, or hydrogen gases. We are using it, and that you can mention in the medium also. Okay, we are doing the heating. Then here we are keeping or holding that component for 1 to 2 hours at approximately 900 to 925 degrees Celsius temperature is used here. And after that, it is cooled with the help of water or oil medium. And at the end, you will end up with getting the case depth 0.2 millimeter to 0.5 millimeter. Okay. Now, these are the important points. Medium used, gaseous medium like methane, ethane, propane, or butane, with the inert gases or carrier gases like helium, argon, or nitrogen. And temperature used will be 900 to 925 degrees Celsius. For 1 to 2 hours it will take. And depth achieved, case depth achieved will be 0.2 to 0.5 millimeter. Now, what are the advantages as compared to the solid carburizing? Here, more thinner cases can be obtained. You can compare here. In the solid carburizing, we will get the case depth up to 1 to 2.5 millimeter, and in this case, you will get 0.2 to 0.5. Means 0.2 millimeter case depth can also be achieved. Means thin cases can be achieved with more uniformity. Okay, here uniformity will be more, and in this case labor cost is very less. We can use the less labors or minimum labors, but whichever labors are there, that should be properly trained or skilled workers are required to control the gas carburizing. Here you have to control the amount of the gases properly. If amount of gases is not controlled properly, some blind spots may occur there. Blind spot means some that spots hardness will means improvement in the hardness does not occur, means diffusion of the carbon does not takes place on the some spots due to the improper control of the circulation of the gases. These kind of defect may be there. To avoid these kind of defects, you have to use the means proper circulation of the gas should be there, and you have to use the skilled operators or skilled workers to perform this operation. So this is the gas carburizing process or heat treatment. Then after this gas carburizing, third third is the liquid carburizing. Now here we are going to use in the liquid carburizing, as name itself indicates that here we are using the liquid medium for liquid carbonaceous medium, and that liquid carbonaceous medium is nothing but the salts. Okay, we are using the salt bath which contains sodium cyanide up to 10%. Salt baths we are using here means in the liquid stages they will present sodium cyanide 10%. Then remaining amount will be mixture of sodium carbonate, sodium chloride, and some elements like barium, calcium, or strontium. These are the just elements which are added to accelerate the process. In the first we have studied that in the solid carburizing we have added barium carbonate or sodium carbonate to accelerate the process. They will just support the process. Okay, in this way here also barium, calcium, or strontium, these elements will be added in the salt baths which contains a mixture of sodium cyanide up to 10%. Along with that some amount of sodium carbonate and sodium chloride will be there. Now here the temperature used to perform this carburizing process is approximately 900 degrees Celsius to 925 degrees Celsius, and this process requires 30 minutes to 1 hour time. And at the end, with hardness, whichever depth is achieved, case depth is achieved, you can achieve the case depth up to zero point 0.1 millimeter, starting from zero point 0.1 millimeter to zero point 0.5 millimeter. So this is the liquid carburizing process. Now here this liquid carburizing process, if you compare all three types solid, gas, and liquid, this liquid carburizing will provide you thinnest case depth along with the more uniformity and with the lesser possible time. Okay, this liquid carburizing will provide the thinnest case with more uniformity and with lesser time. Just proper care should be taken here that as you are using the sodium cyanide in this process, it is highly poisonous in nature, so that it is very necessary to take the proper care for its storage, then use and disposal. Okay, as is highly poisonous in nature. Okay, so this will be the liquid carburizing process. Okay, in this way, we have studied the carburizing along with its types: solid carburizing, gas carburizing, and liquid carburizing. Now, as earlier we have discussed that whichever carbon we are adding, whichever carbon we are adding, that should be transformed to the to the martensite. Whichever carbon is diffused from this medium, it will get dissolved in the austenite, and that austenite you have to transform to the martensite to get the necessary hardness on the surface. And to do this you have to perform quenching process, and that quenching process is done. Okay, that quenching process you can done in different ways. Okay, this is termed as the heat treatment after carburizing. After carburizing, heat treatment is necessary to transform whichever carbon is diffused in the austenite, to transform that carbon in the form of martensite. You have to perform the heat treatment, and it will be termed as the quenching. You can say that quenching or hardening heat treatment you have to perform it, and that heat treatment can be performed or hardening can be performed in four different ways. One, two, three, four. I have highlighted here. One, two, three, four. Okay. These are the four heat treatment processes that you have to perform, that we will discuss one by one. Before this, I have missed this point. It is okay. Whichever during this liquid carburizing, we have used this sodium cyanide. How the carbon from this sodium cyanide, how we are getting the carbon, these reactions will occur there. Okay, this is the sodium cyanide. It will react with the oxygen, it will get transformed to sodium cyanate. This is NaCnO is sodium cyanate. The sodium cyanate, it will again react with the oxygen, and it will give you this sodium carbonate. Then carbon monoxide and nitrogen gas here will be produced, and again this carbon monoxide, it will get decomposed, and it will form carbon and carbon dioxide gas, and this carbon will get diffused. Okay, here these reactions will occur. Either this reaction will take place depending on the medium used, and if suppose you have added whichever accelerator is there, that is the barium carbonate, this second reaction will take place. This second reaction will take place. This will be your second reaction. If you are able to write this first reaction, it is sufficient. But you have to write one reaction. Either you can write this reaction, first reaction, or you can go for the second reaction also. Okay, this will be the reaction in the liquid carburizing. You can note it down if you want. You can note it down. Okay, we will move towards now. After completing this carburizing, means addition of that carbon from carbonaceous medium on the component, it should be followed by a heat treatment process to transform that dissolved or diffused carbon which is dissolved in the austenite into the martensite. Okay, then and then only it will result in the improved hardness. Okay, now here different types of that hardening are there or quenching are there depending on the properties needed. Okay, you can go for four options. First one is the direct quenching. Okay, First one, as it is indicated by the name, direct quenching from this temperature, carburizing temperature. Above 900 degrees Celsius temperature will be here. From 900 degrees Celsius, it is cooled to the room temperature directly in the water or oil medium. Now here you will end up with a microstructure at the surface. At the surface you will get the martensite, whichever austenite, here austenite phase will be there, that austenite will get transformed to the martensite on the surface. Martensite will be there, and as center will be subjected to the slow cooling, at the center fine ferrite will be formed. Okay, ferrite will be formed, and this ferrite will be soft in nature. Hence we will get the hard and wear resistant surface, and core will be tough. Core or center portion will provide you the necessary toughness. Now here proper care you have to take, that if the austenite formed at this temperature, carburizing temperature, austenite is fine, then you will end up with the fine martensite on the surface and fine ferrite at the center. And if coarse austenite is formed at this carburizing temperature, if coarse austenite is present, then we will get the coarse martensite on the surface and coarse ferrite at the center. And coarse martensite will increase the brittleness instead of providing the better hardness. It will improve the, or it will result in the brittleness of that steel. And at the center also it does not provide the required toughness, as the coarse ferrite will be formed. So whenever you are performing direct quenching, you have to take proper care that here fine austenite should be there. Okay, fine austenite should be there, fine and uniform austenite should be there. Then the second step or a second hardening method is the double quenching. Okay, double quenching. Now in the double quenching process, here from this carburizing temperature, component is directly cooled to the room temperature in the water or oil medium. Okay, directly cooled, and again it is reheated above A3 temperature. Above A3 temperature it is reheated. Above A3 temperature it is reheated and again cooled to the room temperature. Due to this first cycle of heating above A3 and cooling it to the room temperature, what will happen, at the core portion fine ferrite will be formed. Okay, here fine austenite will be formed. Above A3 fine austenite will be formed, and it is cooled to the room temperature. Hence at the center we will get the fine ferrite. And again one more heating cycle is given here, and here at this time we are heating it above A1 temperature. Above A1 temperature, holding at this temperature for specific period of time, and we are cooling it to the room temperature. Now in this second cycle, here what will happen, we will end up with the fine martensite, and here we will end up with the fine martensite, and we will get the improved hardness at the surface. In this way, this double quenching method is performed, or double quenching is done. First, it is cooled to the room temperature. Again, it is heated above A3, held at this temperature for a definite period of time and cooled to the room temperature. Here, core refining will occur. Fine ferrite will get formed at the center. And again, it is heated above A1 and held at this temperature for some time, and again it is cooled to the in the water medium, and here we will get the fine martensite on the surface. This process will give you improved hardness, and this cycle will give you improved toughness at the center. So this is the double quenching. Now third and fourth type is just the breakage of this second hardening process, depending on your need. Suppose if you want just increase the hardness on the surface, then this third heat treatment, third hardening process, that is the case refining is used. Means We are cooling the component to the room temperature, and reheating is done above A1 and held at the particular temperature for some 1 or 2 hours, and it is cooled to the room temperature. Here what will happen, and just it is very similar to the tempering process. This is very similar to the tempering process. Hardness will get improved by the elimination of retained austenite, and whichever internal stresses are there, it also get eliminated, and refinement of the case is achieved. That is, hardness of case or surface will get improved. Now, separately, fourth hardening cycle will be like this. Component from carburizing temperature is cooled to the room temperature, then reheated above A3. Here we will get the homogeneous austenite, and again it is cooled to the room temperature, and here we will end up with the fine ferrite at the center. Hence toughness at the center will get improved. Hence it is also termed as the core refining. So in this way, these four heat treatment processes or hardening processes or quenching processes are required depending on the properties needed after performing the carburizing. And you can go for direct quenching, either you can go for direct quenching, double quenching, case refining, or core refining, depending on the properties required or properties needed. Okay, in this way the first surface heat treatment process, that is carburizing, is finished. Some application or some component names on which we can perform this carburizing or applications of carburizings are like this. You can go for some crane wheels are there. These are the name of the components. Crane wheels, support brackets which are used for agricultural tractors, then crankshafts, camshaft, gears, flywheels are there, railway wheels are there, gear tip profiles which we are using, then crane cable drums are there, hydraulic clutches are there. For all these elements, this carburizing heat treatment process is used to get the hard and wear resistant surface and tough center or tough core. Okay, in this way we have finished the carburizing heat treatment process along with its types like solid carburizing, gas carburizing, and liquid carburizing. And in that we have studied their procedure, their purpose, procedure, some advantages, disadvantages, and their applications, and some heat treatment procedure which is required after performance of this carburizing process. And that heat treatment process or hardening process is required direct quenching, double quenching, case refining, and core refining. Okay, in this way we have completed this carburizing process. If you are having any query, you can ask me, and if you are not having any query, I will stop here. Please put that in the chat box. If you have any query, you can ask me, or if it is clear, I will stop here. If you are not having any query, I will stop this lecture here. Thank you for attending this session. In the next session, we will discuss related to the nitriding and carbonitriding heat treatment processes. Okay, thank you.